For case study 6.1, where I had to use a variable control chart of day one stats to then create a histogram, I found the lowest number, which was around 3.74. I used that to create a bin and then added on 0.005 to each number then after. And then from that, I took all the variables, all the numbers from the variable control charts, and found a frequency of which each number was found, which you can see on the right in the highlighted blue where it says bins and frequency. The bins are the numbers and what you can see at the bottom of the control chart, and the frequency is how frequent that length was found. And to answer the question for day one, the histogram for day one looks like a regular hill shape centered around 3.75, and it doesn't spread out much. This means the process was running pretty smoothly with normal variation after using the average range and the D2 value. The estimated sigma comes to about 0.0051, with the sigma and the Z table about 1.25% of the parts are below the lower limit, and another 1.25% are above the upper limit. So overall, around 2.5% of all the parts end up outside the required specs for day one. For part two of case study 6.1, I had to create a X and R bar chart and a histogram combining to day twos and day ones stats. I first made a X bar chart and an R bar chart. I used the stats from the variable control chart and then found the X bar number, which then enabled me to find the UCLX number and the LCLX number. And then after, I found the R bar number, the LCRL number, the UCL number, and input each of those into their own chart. The X bar is on the top, showing the information given from the X bar numbers. The R bar chart is on the bottom, showing the information given for the R chart numbers. The histogram, I had to combine both day one and day two stats. I used the same bin for day ones, but the frequency was more because I used a combination of both day one and day twos. And to answer the question, after adding day two data and making the X bar and R bar charts, the R chart looks normal with no points outside the control limits. That means the variation inside each subgroup is stable, but the X bar chart is different because a bunch of subgroup averages fall outside the limits. And you can see the mean shifting around. This shows the process and isn't stable, so you really shouldn't try to do capability calculations yet for the X bar chart. The histogram for both days together look kind of normal, but a lot of the measurements still fall outside the spec limits. Using the sigma estimate from the R chart and the checking and then checking the Z table, around 10 to 20% of the parts end up outside the specs overall. So the process definitely isn't capable of meeting the requirements, and it needs major improvement before anyone tries to rely on inspection or sorting to fix the problem. For day 3, which is part 3 of the 6.1 case study, I had to create a bar chart and a histogram, not including the past 2 days. So I just repeated for the bar chart and the R chart. I just repeated the steps. I found the X bar with the given information from the stats from the control quality control sheet. I then used that to find the LCLX, the UCLX, fill those out. I then used that to find the R bar, which then helped me find the UCLR and the LCLR, which then allowed me to make the R bar chart and the X bar chart. The R bar chart, which is on top, shows the information given under the X bar chart. The R bar chart on the bottom shows the information given under the R bar chart. For the histogram, I did the same thing. I started at 3.74, found the smallest average number, and then added increments of 0.005 to each one. That then helped me find the frequency of that length. And then to answer the question for day 3, day 3 looks way more stable than day 1 and day 2. The ranges are smaller and the subgroup averages stay inside the control limits from the earlier days. The histogram is really tight and centered, which shows the variation is low using the estimated sigma. Only about 0.8% of the parts would fall outside the spec limits. So day 3 is actually capable of the process and is in statistical control. To explain how I got my X and R charts for part 1, 2, and 3, I first gathered the information from all 3 days on the variable control charts and then organized them in a manageable way in my Excel spreadsheet. I then used that information to find the mean of each subgroup, which then allowed me to find the range of each subgroup. I then found the averages of both X and R, which were used for making the control limits. I then found the control constant for X and R, which allowed me to calculate the control limits of the X chart and the R chart. And to finish it off, I just converted all that information into a line chart with markers. Finally, to explain how I created my histograms, I converted all the information from the variable control charts from day 1, 2, and 3 into my Excel spreadsheet in separated parts for each day. I then found the lowest number and used it to start off my bins. I then added my first bin value of 0 I added to my first bin value a value of 0.005, then kept adding until there was no more values in that range. I then calculated the frequency of how many numbers fell in that range using Microsoft Excel's frequency formula. And to finish it off, I then converted all that into a 2D bar chart to finish it off.